So, good day everyone. Good day, sir, and good day to my fellow classmates. So, my topic is all about the need for normalization. Normalization is typically used in conjunction with the entity relationship modeling. So, normalization is a process used in the database design and to eliminate redundancy and improve data integrity. So, it involves organizing data into multiple tables and establishing relationships between them. So by reducing data duplication, normalization helps to ensure efficient storage and retrieval of information. Next is the database designers commonly use normalization in two situations. So we have designing a new database structure and modifying an existing database structure. So here, in designing a new database structure, we have the ER modeling. So when designing a new database, the process typically starts with conceptual modeling, often represented using techniques such as entity relationships, diagrams or ERDs. So with notations like crow's foot. So in ER modeling, in the process of designing a new database, ER modeling is used to create a conceptual representation of the database structure. So this involves creating an ERD that visually depicts that entities, objects or concepts and the relationship using notation like crow's foot. So in identifying entities and attributes, the database designer works with end users to identify the entities, objects or concepts and their attributes, properties or characteristics. So the database designer collaborates with end users to identify the entities in the database such as customers, products, or orders. So attributes, which are the properties of characteristics of these entities, are also identified. For example, a customer entity may have attributes like name, address, and emails. So in relationships, the relationships between entities are established, indicating how different entities are connected. So once the entities and attributes are identified, the next step is to establish relationships between the entities. So this indicates how the different entities are connected or interact with each other. So for instance, a customer may have a relationship with an order, indicating that a customer can place multiple orders. So in normalization, after the initial design is complete, the normalization is employed to analyze the relationships among attributes within each entity. So the goal is to organize the data in a way that minimizes redundancy and dependency issues, so leading to a more efficient and maintainable database structure. So after the initial design is complete, the normalization is applied to ensure data integrity and eliminate redundancy. And it involves analyzing the relationships among attributes within each entity and organizing the data in a way that minimizes duplication and dependency issues. So by doing so, the database structure becomes more efficient and easier to maintain. Okay, next to the modifying an existing database structure. So analyzing existing data structures, the database designers are often tasked with modifying existing data structures, which can range from flat files and spreadsheets to older database systems. So when modifying an existing database structure, the designers first analyze the current data organization, which can include the flat files, spreadsheets, or older database systems. So in relationship analysis, the designers analyze the relationships among the attributes or fields in the existing data structure. So, in the relationships between the attributes or fields in the existing data structure are examined to understand how they are connected. Next is the normalization process. The normalization process is then applied to the existing data structure. This involves breaking down large tables into smaller related tables and organizing data to meet normalization standards. So, the aim is to eliminate data anomalies such as update, insert, and delete anomalies and improve the overall structure for better for performance and maintainability. So, in the normalization process is then applied the restructure the data. So, this involves breaking down large tables into smaller. So, related tables are organizing the data to eliminate anomalies and improve performance and maintainability. So we have a table for figure 6.1, a tabular representation of the report format. So the table of this image is a tabular representation of a report format. As indicated by the title above the table, it contains the columns for project number, project name, employee number, employee name, job class, change hours, and hours. So the table shows the following information. So the project number and name of each project, the employee number and name of each employee involved the project. So the job class of each employee indicating their role and responsibility, and the change hours of each employee indicating their hourly rate, and the hours of each employee indicating how many hours they work on the projects. So this table can be used to generate a report on the progress, cost, and performance of each project and employee. That the data in figure 6.1 reflect the assignment of employees to projects. So apparently, an employee can be assigned to more than one project. For example, Darlene Smithson, the employee number is 112, has been assigned to two projects, Amber Wave and Starflight, given the structure of the dataset. So each project includes only a single occurrence of any one employee. So therefore, knowing the project number and employee number values will let you find the job classification and its hourly charge. So, in the data set shown in figure 6.1, the employees can be assigned to multiple projects. For instance, Darlene Smithson is assigned to two projects, Amber Wave and Starflight. So, each project has a unique occurrence of an employee. By knowing the project number and employee number, one can find the corresponding job classification and hourly charge for that employee. Okay, we have another table. So, table 6.1. The table of the image is a sample report layout for project management. So, it shows the following information. So, the project number and name of each project, the employee number and name of each employee involved in the project, the job class of each employee indicating their role and responsibility, the charge per hour of each employee indicating their hourly rate, and the hours billed of each employee indicating how many hours they work on the project. So, the total charge of each employee indicating how much they earned from the project. So, the project leader of each project indicated by an asterisk next to their name. So, the table can be used to track the progress, cost, and performance of each project an employee. So unfortunately, the structure of the data set in figure 6.1 does not conform to the requirements discussed in chapter 3, nor does it handle data very well. So considering the following deficiencies, the project number is apparently intended to be a primary key or at least a part of a PK, but it contains nulls. So given the preceding discussion, you know that project number plus employee number will define each row. So in the data set shown in figure 6.1, there are some deficiencies in the structure and handling of data. Firstly, the project number is intended to be a primary key or part of a primary key. So, but it contains null values. So this means that there are missing or incomplete project numbers, which can lead to difficulties in uniquely identifying and retrieving specific rows. So, however, by combining the project number with the employee number, it is possible to define each row uniquely. So, the table entries invite the data in inconsistencies. For example, the job class value, we have electric engineer, so might be entered as elect that eng in some cases, or el that eng in others, or and ee in still others. So the table entries invite data inconsistencies. For example, the job classification or job class. So value electric engineer may be entered differently in different cases, such as elect.eng, l.eng, or ee. So this inconsistency in data entry can lead to difficulties in data analysis and retrieval. So it is important to establish standardized formats and guidelines for data entry to ensure consistency and accuracy in the data set. So the table displays data redundancy that yield the following anomalies. So first, we have update anomalies. So modifying the job class for employee number 105 requires many potential alterations, one for each employee number equals to 105. So in update anomalies, modifying the job classification of job class for an employee with a specific employee number requires making multiple alterations. For example, if employee number 105 changes job classification, it would require updating all rows where employee number equals to 105. This redundancy in data storage can lead to inconsistencies and difficulties in updating data efficiently. So in insertion anomalies, just to complete a row definition, a new employee must be assigned to a project. If the employee is not yet assigned, a phantom project must be created to complete the employee data entry. So, to complete a row or data for a new employee, they must be assigned to a project. If the employee is not yet assigned to any project, a phantom project must be created just to enter the employee's data. So, this can result in unnecessary or fictitious project entries, so leading to data redundancy and confusion. So next is deletion of anomalies. And suppose that only one employee is associated with a given project. If that employee leaves the company and the employee data are deleted, the project information will also be deleted. So to prevent the loss of the project information, a fictitious employee must be created. Suppose only one employee is associated with a particular project. If that employee leaves the company and their data is deleted, the project information will also be lost. So to prevent the loss of project information, a fictitious or placeholder employee must be created. So this introduces unnecessary data and can make it difficult to accurately represent the absence of an employee for a project. So these anomalies highlighted the need for proper normalization and data management techniques to eliminate redundancies and ensure data integrity. For example, If you want to print a report to show the total hours worked, value by the job classification, database designers that report will not include data for DB design. And database design data and research reporting anomalies cause a multitude of problems for managers and cannot be fixed through application programming. In the given example, if you want to print a report showing the total hours worked by the job classification, database designers, you may encounter reporting anomalies. So these anomalies arise due to inconsistencies in the data entry, such as using different variations of the job classification term like DB design and database design. As a result, the report will not include all the relevant data for the desired job classification. So these reporting anomalies can create challenges for managers who rely on accurate and comprehensive reports. And they cannot be fixed solely through application programming, and it highlights the importance of data standardization and normalization to ensure consistent and reliable reporting. So remember that the naming convention makes it easy to see what each attribute stands for and its likely origin. For example, project name uses the prefix project proj to indicate that the attribute is associated with the project table, while the name component is self-documenting as well. However, keep in mind that the name length is also an issue, especially in the prefix designation. For that reason, the prefix CHG was used rather than charge. So, given the database context, it is not likely that the prefix will be misunderstood. So, the naming convention used in the table follows a pattern that indicates the attribute's association with a specific table. For example, project name signifies that it's related to the project table, and the name component is self-explanatory. So, however, it is important to consider the length of the prefix to avoid confusion or readability issues. So in this case, CHG was used instead of charge. So that's all. Thank you.